All right, we're going to take a look at some highlights with regards to parabolas. Uh, so a couple of examples here outside of our main lesson. I've got a general form up here, and we see these general forms in a lot of different ways. But the one thing that I want to focus on and make sure that I know is that H is always with X, K is always with Y. My vertex of the parabola is always going to be HK, H comma K. There's my vertex of the parabola. Now, as far as the other pieces, P, we'll see a variable here. Oftentimes, we'll see this variable as A. So, just to kind of signify here, it really doesn't matter what variable's there, it's just a variable. So, A would refer to distance from vertex to focus, as well as vertex to directrix. If there was a P there, which sometimes we will see in a general form, still means the same thing. P would be distance from vertex to directrix, vertex to focus. It's referring to a distance. A lot of times in a general form, we'll see a plus or minus right here, which is how it is sometimes presented, just kind of saying, hey, it could be positive or negative. However, there are times when we're just showing a general form that plus or minus would be left out. And that being said, it's still referring to a plus or minus. So just make sure we understand. If I saw this, plus or minus and an A, plus or minus and an A, it's just a generic general form. The plus or minus means, hey, we could be talking about a positive or a negative oriented parabola, in either case with the Y or the X. And then again, that variable, then also that variable A, distance from vertex to focus, vertex to directrix, that you saw on the main lecture video. So just to kind of give us a different look, I'm now just going to look at it with just the P's there. So we just get used to seeing it that way as well as we saw it the other way. And we can realize what the pieces are. So again, P in this case, distance from vertex to focus and vertex to directrix. Now, in the main lecture video, went through a lot of different examples and focused on the fact that we've got to know first off which way these things are facing. Is the parabola opening up? Is it opening down? Is it opening to the right? Is it opening left? And that's still the case here. But I'm just going to kind of look at a couple of different examples here that give us some fractions, complete the square, just some additional pieces to kind of solidify some things here. So first off, I know it's a parabola, only one variable squared. Here the x is squared, not the y. Here the y is squared, not the x. So let's look at just a general one here. Let's say that we have, let's go y minus 1 squared equals negative 5x plus 3/2. X plus 3/2. So just trying to get some ones up here with fractions. Fractions are sometimes kind of a pain. But when I look at this, what I first want to realize is which way this parabola opens. So as soon as I see this y being squared, I know that means it's going to be opening to the right, something like that, or to the left, something like that. The negative is what's cluing me in there, right? The fact that there's a negative means that, hey, we're going to be opening to the left. So when I see this general equation, I know that this is a parabola opening left, And sometimes it's helpful to just kind of have a simple little diagram there. Just kind of reminding me, hey, I've got one opening this way, I've got a vertex here, and then coming back to the left. My vertex. All right, we have HK. So I always want to remember that H is with X, K is with Y. So here's my H value. And it's supposed to be X minus H, so that's going to make that H value negative 3/2. And that Y value on my vertex of 1, because that K is 1. Okay. Now, as far as some other pieces, we'd like to figure out where the focus is, the directrix. We already have the vertex. So for me to figure that out, I need to know what that P value is. I need to know what this guy is right here. Right? And in this case, P would equal 5/4. Again, another fractional value. Now, where I'm getting the 5/4, I'm looking right here where the P is supposed to be. I've got a 5 there. Well, where there's a 5, there's supposed to be a 4P in a general form. So that would mean 4P equals 5, which means P would have to be 5/4 would be that value there. So there's where I'm coming up with that distance. Now, just a reminder, the negative doesn't have anything to do with the distance. Okay, the negative said which way it was opening. I know it's opening left. Okay, distance is positive. We're just saying we're 5/4 units from the vertex to get to the focus and to the directrix. So my focus and my directrix. Focus, directrix. Okay. So the focus is going to be the point inside the parabola. So in this particular case, I'm going to be moving 5/4 units to the left of the vertex. So that would mean that the y coordinate is not changing. It's going to be still at 1. Okay? And if I do negative 3/2 minus 5/4, and I'm thinking, if I'm not so good with fractions, I'm going, hey, negative 3/2, all right, minus 5/4. Well, that would be negative 6/4 minus 5/4, or negative 11/4. Okay. Now, sometimes we run into situations where fractions are kind of easy to deal with. Sometimes we run into situations where they're a pain. Please remember, you can certainly use decimals here. I can certainly use decimals here. I can also use a graph. Okay. Let's say I struggle, just a reminder here, I struggle with points moving left or right or what have you from that vertex. The first thing I would want to do then is plot my vertex. So if I just kind of get a graph here, and let's see, my vertex, negative 3/2, 1. So negative 3/2, 1 will put me right here. And what I know is my general shape is going to come around, and I'm just saying a general shape, and it's not going to be the most perfect parabola, but it's got to be coming around something like that. And I did a pretty bad job of graphing there, but you get the idea. I've just got a parabola coming around here. Where exactly does it cross the x-axis? I don't really know at this point, nor does it really matter. I'm just trying to get a general shape there. That's our focus, that general graph. I've got the vertex, negative 3/2, 1. So I went negative 1.5 here, up 1, and I know it's opening left. This sometimes can help me. All right, I'm going to move 5/4, and the focus has got to be inside the graph. So that means I'm going to go 5/4 units this way. So it's got to come this way. That means the y value is going to stay the same. and we're going to end up at negative 11 fourths, or I could do negative 2.75. I could do negative 2 3/4 if I want a mixed number, fraction. It doesn't matter to me. I've got to just get that location. So if I'm not so good with fractions, maybe one of the things I want to do is change that to negative 1.5. So I'm at negative 1.5, and I'm going to move 1.25 this way. So negative 1.5 minus 1.25 is going to put me at negative 2.75 right there, which is the same as that value. So I want to make sure I get a fraction one up here so we can kind of see, if I'm a little confused, like go to decimals, draw a picture. I can kind of get some pieces there to kind of help me out. Directrix. Well, the directrix is going to be behind the parabola. So it's going to be that vertical line this way right here. Now, where is it at? It's a vertical line, so I know it's x equals. Okay. And it's 1.25 or 5/4 units to the right of that. Okay. So that's going to be at negative 1/4. Okay. So again, I'm at negative 3/2. And I'm going to be adding 5/4 this time, so negative 6/4 plus 5/4. There's where I'm getting that negative 1/4. So I've got a directrix sitting right in here, negative 1/4. And again, if I'm not the most comfortable with fractions, by all means, I'm at negative 1.5. I'm going to add 1.25, and that would put me at negative 0.25. Decimals are also fine. Test questions, homework, I don't care if it's in a fractional form or decimal form, but what I definitely want to do is not be afraid when I'm seeing a fraction show up in here or that distance value ends up being a fraction. I can deal with that piece. It might slow me down a little bit, but I can deal with that. Notice, very similar to the lecture video, first thing I worried about was, hey, which way does it open? I see the y squared. It's going to be a left or right. I see the negative. That's going to open to the left. So I have a general idea of what this looks like. Our other type involves completing the square. Now, prior to the parabolas, the completing the square was done with circles back in 1010 or previous course to this one. Learning the actual operations of completing the square, same thing, previous course or Math 1010, and then it was applied to in the circle. So let's look at it in the context of a parabola here. So here's my parabola. 25x squared plus, plus 20x plus 5y minus 1 is 0. Okay? And again, I'm grabbing one here that's likely going to create some fractions and stuff to just kind of see how things are moving around. Now, I know this is a parabola simply because the x is squared and the y is not. That's enough to tell me I'm looking at a parabola. Which way is it oriented? At this point, all I know is up or down because I've got the x squared. That's about all I know at the moment. Okay? So what I want to do is complete the square with these x's here. I need to complete the square with this guy right here. Because I need this x minus h. I'm going to have x plus or minus a value squared. Something along those lines. Okay? So first thing I'm going to do is get that the 5y and the 1 to the other side, so I'd have negative 5y plus 1. Because this is my focus, completing the square with this, everything else would be over on that right side. Now, to complete the square, the leading coefficient must be a 1. We're going to see where the leading coefficient's not a 1 coming up in some other of our conics that we're going to work with. in ellipses and hyperbolas. We've primarily seen on the parabolas where that coefficient's 1. So I wanted to get one in here where it's not 1. So what do I do if it's not a 1? Well, first thing I'm going to have to do is factor out that 25 so I get a 1 here. Now, again, factor out 25. 25 times x squared is 25x squared. So then if I factor out the 25 from the 20, okay? All right, 25 from the 20, I'm just going to write it like this, 20 over 25x. Now, sometimes it's kind of tough to visualize factoring out that 25. So I like to think of it as just kind of multiplying back through. Okay, that would be 25x squared. And if I did 25 times this, well, the 25s would cancel, leaving me 20x. So this is the same representation as that. Now, I do like to have my fractions reduced. Okay. So I can reduce this guy right here. I don't necessarily have to have them reduced all the time, but I do like them reduced. So this would be 4/5 x. And again, still equal to negative 5y plus 1. Okay. Now, it's really tough a lot of times to see, well, wait a minute, if you factor out a 25, getting 4/5. So this intermediate step, when we have to factor out a number, is very helpful. Okay? So if I take out that 25, I'm going to have 20 over 25 right there. Now I can see to reduce that guy. That might make it a little bit better for me. Right? So completing the square. Here we go. 25 x squared plus. Right? For our completing the square, what we did from the lesson was we took half the linear term, squared it, added it to both sides. So half of this linear term, half of 4/5, I'm going to put that down, half of 4/5 would be 2/5. Half of 4 is 2. So half of 4/5 would be 2/5 squared. I'm going to put an intermediate step in there showing what I'm squaring. And then I've got to add this to both sides. All right, here. I'm going to add this guy to both sides. So let's kind of see what's happening here. 2/5 squared. 2/5 squared is really 4/25 if I were to square it. Now what that means is if I did 25 times 4/25, so again, if I distribute this back here through, I'm going to get 25x squared, 20x, and then plus 4. So what's happening is I'm really adding 4 to the left side, so that means over here, I've got to go add 4. It looks at first like I'm adding this value, which is 4/25, but what I need to remember is I'm really adding 25 times that, which is just going to be the 4. So on the right side, I'm adding my 4. So my next step, 25 x plus 2/5 squared. Factor, there's my completing the square, negative 5y plus 5. Well, 1 plus 4 is 5 over there. I'm getting closer to this generic form right here. I'm just going to go ahead and erase the bottom one. This is what I'm looking for since I had x squared. I can see my square here. I can see some y's over here. I'm getting closer. No coefficient here. That's going to tell me get rid of that 25. So if I divide that 25 over, I'm going to have x plus 2/5 squared equals negative 5y plus 5 over 25. I've got the left side looking good, right side not looking so good, but I'm on my way there. So now what I'm going to do is I'm going to factor out a negative 5/25. See a 5 in common up here. There's my 25. I'm going to factor out a negative because I want that positive, and that would give me y minus 1. Again, sometimes the fractions get to us, so I can check this. A negative 5 over 25 times y is negative 5 over y over 25. Negative 5/25 times negative 1. Hey, that's positive 5/25. I've got that there. Okay. And my last step here, just to kind of get it reduced down to this nice form, would be a negative 1/5 y minus 1, because I can reduce that 5 over 25. Okay. Now again, this particular problem, completing the square and stuff, a lot messier than the ones on the lecture video. But that's because I wanted to kind of get a fraction in here. I wanted to remind us from our previous course, or your previous course, I should say, or 1010, where that leading coefficient's got to be a 1. It's forcing me to do something like this. We're not going to have to do that every time, but we're going to see it a couple more times in the future. So just kind of getting this out of the way now to kind of say, all right, we've seen it. Doesn't make it easy, but we've seen it. All right, I'm going to kind of remember in the future what I can do. I can look back at this and go, all right, I got to have a 1 there. This is now my standard form of that parabola. So let's look at some pieces here. First off, I know this parabola opens down. So in other words, it looks something like that. I know that because x is squared, which means it opens up or it opens down. And I see the negative, so that's going to give me that down position. In that standard form, I can now tell where my vertex is. Vertex is that HK. So vertex would be negative 2 over 5. There's my H. H is always with x. And my K value would be 1. So there's my vertex. I'm going to go through on this one. We're going to find the focus and directrix, but I need that P value. So in this case, P. I'm looking right here and going, all right, what would that P value be? And that's tough with a fraction there. So one of the ways that I mentioned earlier for dealing with it was, hey, what if we said 4P is 1/5? So 4P is where that 1/5 is. So let's say we had that. 4P is 1/5. And if I go through and solve this for P, 20P is 1. P is 1/20th. There's that P value, 1/20th. So again, I multiply both sides by 5. Give me 20P is 1, divide by 20, 1/20th. And now I can work my focus, my directrix. So here my focus would be negative 2/5. Now, I just you can go plot it like I did before and get the vertex and such, kind of count down. But sometimes I can just kind of look at this guy right here and go, all right, here's my vertex. So if I'm going to go 1/20th units, I'm going to have to go down 1/20th to stay inside here. Right? That means the x value is not going to change. When I move up and down, that changes the y value. So that means my y value, if I go down, would be 19/20. So in other words, it's 1 minus 1/20. 1 minus 1/20 would be 19/20. If you'd rather work with a decimal, again, that would also be fine. Directrix this time. My directrix would be y equals. It's going to be a horizontal line. Again, I can plot as I go, like I did on the previous one, or looked at on the previous one, even did on the video, lecture video. Or I can look right here and go, all right, if it opens like this, well, the directrix has got to be a horizontal line sitting above it. So there's going to be my y equals, which would be y equals 21/20, because it would be 1/20 above 1. So 1 plus that 1/20 there. All right. Let's look at one other one here. So the focus again here, working with some of those fractions. We didn't see a lot of fractions. I want to get the fractions in there. Decimals are also fine. All right. Let's look at the other way around where we need to get an equation for, say, a parabola. So I'm going to say, find equation, and we're still in a parabola. So I'm going to say this time the vertex is 1, 2. I got a vertex at 1, 2, okay, and a focus at 1, 1/3. 1, 1/3. So I'm still dealing with a situation here where I've got some fractions involved. Situation here where I've got some fractions involved. So that being said, okay, one of the things I do need to figure out first and foremost is which way this parabola is opening. Is it up, down, left, or right? Sometimes I run into situations where it's kind of easy for me to tell which way it's going to open. As long as I've done this, there's still times like, which way is this thing moving? One of the best things I still say we can do is plot what you're given. You'll visualize or then be able to see which way it's opening. So in this particular case, if I were to plot the vertex 1, 2. So I've got 1, 2. Let's put a V for vertex. I plot the focus. 1, 1/3. All right, F for focus. Now I can kind of visualize which way this parabola has to go, because what I remember is the focus is a point inside the parabola. So if the focus is a point inside the parabola, it looks something like this. Now again, this is not my exact parabola, but it gives me an idea. It's got to go down to keep that focus inside. As soon as I know it's going down, here's my standard form. I know the x is squared, x minus h squared. I know I'm going to have a negative there. And again, I'll use p at y minus k. Just because I had p up here earlier, we talked about, we don't care what the variables. Variables are variable. Okay? So I have the vertex 1, 2. So I'm going to have x minus 1 squared, y minus 2 squared. I can go ahead and get my h and k in. H goes with x, k goes with y. Focus. All right, I need that p value. So we go ahead and put my -4 here. Again, I know it's negative at open down. 4 part of my standard form. Let's go get that p value. P was the distance from focus to vertex, or vertex to focus. So this distance right here. So I am going from a value of 2, y value of 2, to a y value of 1/3. Right, so that's going to be a p-value of 5/3 or 4/3. It's going to be 5/3. 5/3 distance. Now, here's all I did. 2 minus 1/3 will give me the difference in the y values. So that's 6/3 minus 1/3 is 5/3. Again, decimals would also be okay if you're not comfortable with the fractions, but I've got a 5/3 p-value. Here's my 5/3. X minus 1 squared, negative 20 over 3, because I can multiply 4 times 5/3. Y minus 2, there is my standard equation. So again, the main idea focusing on these highlights here were to get some work with the general form, to also discuss that sometimes variables switch around, p's versus a's, it's just a variable. Right? Sometimes in a general form we can see a plus minus, sometimes not, but it's just a general form. I wanted to make sure in all three cases I got some fractions up here. Didn't have a lot of fractions in the lecture video. We don't see a ton of fractions, okay? Not this early on. You get some other levels of mathematics, the fractions start coming more and more, but we are going to run into them. We want to get comfortable in the fact that sometimes we need to get a common denominator. We want to get comfortable in the fact that I could also use my calculator, my scientific calculator that I have, or I could even go to a decimal if I wanted to for getting those values. There's nothing wrong with that. But seeing how some of the pieces do move around. Okay. Now, completing the square when it becomes a fraction, generally a lot more difficult than just a regular completing the square, but wanted to get one up here where we can kind of see what's happening. We're seeing the same idea of, hey, leading coefficient's got to be a 1. Half the linear term. Square it, add it to both sides. I do realize that working with it when it's fractions, it becomes a lot more difficult, but we want to just focus on that process for that piece there. So that's to help you with some highlights or additional pieces for that parabola video. Kind of getting some fractions in here, see how some things move around, understanding the orientation of where the focus and the directrix are. Compared to the vertex, it's going to be that distance away. I really think that a lot of times sketching it as you go or putting a brief sketch of the orientation, like when I had one opening left, I just put it opening left or down. Or if I need an equation, we'll go plot those 2 points and you can kind of visualize which way it's going. That does help. It doesn't take very long to plot a couple of things, but it can help with getting that orientation down.